Keynote profile, Harikrishnan Ramakrishna Pillai, Research AI in Distributed Systems, USA. His expertise includes artificial intelligence and large scale distributed architectures, large scale distributed platform architecture, generative AI powered enterprise solutions, scalable data architecture and intelligent system, AI-driven innovation in enterprise ecosystem. So as today's topic is generative AI, reshaping commerce and society. So let us warmly welcome Harikrishnan Ramakrishna Pillai.
Thank you. Can I please share the slides? Thank you all. So my name is Harikrishnan Ramakrishna Pillai. I work as a director of software engineering for a leading technology company. So I think we already heard a lot about generative AI from the previous speaker. This is very a foundational topic. I'm not really talking detailed about specific use cases. So this is just an introductory talk on generative AI. So let's get started. So we just look at how the AI evolution started and how we got here to the generative AI world, right? So in 1950s, we started with rule-based AI. Whether we write a rule, can be a simple if-else statement, but it works well. But there is no learnings or any intelligence there other than the logic works. This is hard-coded logic, right? So then we move into machine learning from 2000s to 2010 timelines. Whether what is machine learning, as we all know, we learn patterns from labeled data. We have a lot of data. We started generating a lot of data from that point of time. So we start labeling the data and then we start learning from that patterns based on the training data and we make predictions or classifications. So machine learning is all about looking at historical data and predict future scenarios or classify based on the labels, right? So then we get into the advanced machine learning, eventually from 2012 onwards, deep learning, whether we start applying neural networks, just the way human brain works, and which has a lot of applications in image matching, speech recognition, etc. Whether we rely on deep neural networks, right? So moving on, we get to foundational models, 2020 onwards. This is where all the large language model revolution starts, and we started with massive pre-trained models with the billions of parameters, right? And then that is a foundation for generative AI, whether these pre-trained models help us to generate new content. It can be text, it can be images, it can be decisions at scale. But essentially, the foundational model came out from ChatGPT, Claude, Anthropic, and Google Gemini. Those kind of models basically pave the way to produce intelligent new text, code, or even decisions at scale. So moving on. So what is the foundational difference between between foundational AI and generative AI, right? The purpose of foundational or a traditional AI is you analyze existing data, you classifies or predicts based on that, right? The input is always a structured, so you label the data and then you predicts based on that. And examples are spam filters, fraud detection. These are all use cases we leverage machine learning efficiently, and still we haven't replaced machine learning yet with any generative AI or agentic AI technologies, even though we are driving in that direction, right? So the learning is always based on labeled data for specific task and the importance of traditional AIs is very task specific, right? So you basically want to create a prediction on whether inventory optimization or stock market or classify emails as spam or not spam. So these are a specific task you are doing, and then you look at the data related to it, you label the data, you train the data, and you execute the task. Works well, right? And we have a lot of data to produce it. So generative AI, the purpose is slightly different, whether it's about generating new content, whether it's text, images, or intelligent decisions, right? So the input is a natural language prompt. It is unstructured data. You can basically provide an image as an input and ask for different variations of the image. So you are essentially generating new capabilities out of it, right? Examples are ChatGPT, um, Copilot. Copilot is just a tool, but it's internally using LLMs at scale. So learning is pre-trained on vast internet scale data with billions of parameters. If you look at our traditional AI, we are talking about maybe less than hundreds or thousands of parameters based on different use cases. But here we are training on vast amount of data with a billion parameters. The flexibility is that these models, the foundational models with generative AI are general purpose. It can actually solve a wide variety of problems compared to a specific task, whether the ML algorithms were focusing earlier, right? So I just explained some of the core concepts behind this. These are all complex topics which requires dedicated sessions. So LLM is foundational for generative AI terminology, whether it's a large language model, it's no magic, it's a neural network trained with billions of parameters. And that's why training such an infrastructure, training such a complex model requires a very powerful infrastructure. That's why we're talking about specific chips, etc. from NVIDIA, which is not possible earlier, which we do have the capability to train on such trillion or billion parameters at this point. So prompt is an important term in the overall generative AI. So prompt is technically an instruction to the AI to better produce an output. And the prompt engineering itself is a complex topic, whether you can basically leverage different concepts like temperature, etc., to produce more specific details versus more creative. So there are a lot of tunings we can do. It's not just about sending an English text or a language text, right? So tokens are critical as a piece of unit of text. Everything in LLM world work as a token. It is a foundational monetization part, and the capability of LLM depends also on how many tokens it can produce, right? It's just like a working memory. So another important thing is RAG. So the RAG is retrieval augmented generation. So where we are leveraging RAG is that, so when we are asking a prompt to an LLM, so you basically get very general purpose related output, right? So, but if you really asking for a specific question which requires very specific information about the use case you are looking at. So example, you are talking about a medical advice, right? Definitely LLM can give a general medical advice based on what it knows from the internet. But if you really want to specify more specific details about your case, it also need to learn about the medical history. So you can use techniques like retrieval augmented system, whether you can index your local data, whether a prompt, before you sending a prompt to the core LLM, you can filter with the retrieval augmented generation systems to specify the context more to the LLM so that it can produce more specific use cases for you rather than providing a general medical advice, right? So embedding is another important term. So embedding was existing before, but with the generative AI technology, this becomes more useful. So embeddings can provide you more semantic meanings. For example, earlier when you are searching for ice cream and vanilla, it has no obvious connection in a keyword search. But with the semantic meaning, ice cream and vanilla is connected, and then you should be able to retrieve similar meaning or related words like that with the vector embeddings technologies. So fine tuning is also a capability whether all the LLM providers are giving. Just like a RAG, fine tuning is another way whether you can tune your model with LLM by providing specific pre-built specific data or domain data pertaining to you, so that the LLM can produce more specific knowledge or context for you. So these all capabilities, just like a pure ML, this also provides all the capabilities from a generative AI world. It's not like there is no training, everything is automatic. It's not the case. There are a lot of capabilities need to be built, and these all techniques has to be followed to efficiently generate or efficiently solve your use case with the generative AI. So high level, how generative AI works, you ask a plain language for a task. Example is 5 product title. It retrieves. You can use embeddings, you can use RAG to power up your prompt for a more specific ask to the LLM, and it generates the data, and then an action is taken. Basically, your content is being delivered, right? So it's so simple. It's not just like looking information from a database. It generates responses using your prompt, learned patterns and the context, and mainly based on your instructions. So this is just a number, and some of them look scary, but this is where we are heading to. Potentially, the OpenAI research is saying 80% of the jobs can be impacted or changed when we are entering into a generative AI world, right? If you look at the productivity gain, at least for software developers, we are seeing 10x productivity gain in the market, and for every Fortune 500 company, the generative AI is the number one investment at this point, high level. So these are some of the important use cases, which basically, at least from an e-commerce industry, product discovery is very critical. Earlier, we used to have keyword search based product discovery, whether you are searching for, for example, iPhone 16 or iPhone 16. So you basically, based on your inverted index, you retrieves it, right? So now conversational search is being introduced as part of generative AI. So you can ask for a show me blue sneakers under $80. So this is mostly semantic or intent-aware recommendations. And then you can ask for visual search. Example, you can upload an image for a shirt or a t-shirt, ask similar t-shirts from your search. So all these are possible with the advent of generative AI technology right now. The next use case particularly is very critical, content at scale, right? So with the advent of generative technology, now the e-commerce organizations can produce thousands of product descriptions, which simplifies the whole third-party item setup or a product setup, which used to take minutes or maybe hours or days, which can be right now reduced to seconds, whether the system itself, if you provide a UPC or just a keyword or a text, it can find your category, look at the specification, and generate majority of the data. And then the third-party merchant just need to look into it, maybe correct some of them and just submit, right? So similarly, customer support, personalization, merchant operations, business intelligence are all impacted or being innovated through generative AI. So these are not theories anymore. These are things which are already working at scale in a lot of Fortune 500 enterprises. So we moving from generative AI to agentic AI. So generative AI is essentially you provide an instruction, you get it. It's mostly like a single task, right? But we are moving from agentic AI from answering to acting. So generative AI is more about answering, but agentic AI is about acting. So example, you can ask that, hey, this is a UPC, set me a product for the seller. So that essentially means that there are multiple tasks involved, right? You need to really parse the instruction, identify the intent, look up the category or a specification for that particular product, identify the attributes associated with it. Then you need to really show the information back to the third-party merchants. Then based on their information, you need to save the data. You need to really send emails associated with it, generates reports out of it. So there are multiple things, whether normally different systems or humans does. With the AI agents or agentic AI capability, all these tasks can be done just like the way human is doing with a simple instruction from the third party merchant or an email. For example, someone can simply parse the email, do this for me, and the whole setup can be done, taken care by agents. So just want to touch upon MCP. So the model context protocol is very, very foundational protocol leverages in the agentic AI world. There are a lot of technologies like A2A, ACP, ANP. These are all equivalent technologies to provide agentic implementations. But MCP is very popular, built by Anthropic. So before MCP, consider MCP as a USB for AI. For example, when you are providing an instruction to a task, this essentially is not a simple task. It involves multiple tasks, just I mentioned, right? Creating a product, sending an email, generating a report. So for each of them, you require a tools to be created. For example, something to save to database, fetching from information, generating an email, or generating a report, or sending an email, right? All of those requires different toolings. Whether MCP is basically a standard protocol, whether these toolings can be abstracted, and when an instruction is given to a chat bot or an agent, all these things can be combined properly to finalize this task well. So before MCP, this was possible, but a lot of custom implementation, when you change API, it breaks, there is no standardization there. So what MCP basically built that standardization just like a USB for the AI. So product catalog, inventory management, order management, all of these toolings can be built and connected. And these are intelligent. It learns from the history, it learns from your past interactions. So at some point, complete human interaction can be avoided and everything can be done with the agent-to-agent communications. So this is just a reference architecture. As you can see, whether a particular third-party merchant asking to set up an item. So this is my UBC, please set up this item. So essentially, there's an LLM chat session which identifies the intent, look at, query the MCP protocols, list different set of tasks needed to complete that particular instruction, query the MCP server. Okay, where is the product DB? Give me the product. Where are the guidelines? Where is the order system? So all of those things will be properly connected in sequence and get the job done. So this is not theory anymore. This is being used and leveraged by major industry day to day. And that's the most interesting part of the equation. So if you look at an AI-powered product setup, an end-to-end flow, a merchant asks, okay, I'm listing a portable blender. What attributes do I need? And this is my product ID or SKU number is being given, right? So essentially the implementations powered by an LLM understand the intent, it start doing the entity extractions, identify the product type, pull up the spec, show the data to the seller. Once it finds system calls the MCP, find what all needed. For example, fetches category taxonomy. That can be one tool. Fetching required attributes can be another tooling. Compliance rules can be another tool. All this will happen properly with a simple instruction coming from the merchant, right? And then your product is being set up. So typically it used to take days, not even minutes. Now these things can be done under 30 seconds and there is no human agent needed for performing all of those things. And you can imagine the savings, the productivity advantage coming to organizations and the third-party merchants at this point. So this is just an information, the different dimensions when we are moving from a simplified generative AI to agentic AI. You can see from response times, availability, scalability, accuracy, everything is being changing drastically. So if you look at, we are at this agentic AI world where everything is being autonomous from simple instruction level task generated used with the generative AI. So business impact, these are numbers, these are not, some of them are illustrative outcomes, but these numbers represents the industry in terms of 85% of merchant queries are resolved by AI without human right now, starting from e-commerce, search, majority of the support cases are taken over by agentic AI. You can see a lot of productivity improvements and then millions of dollar savings annually. So operational efficiency, merchant efficiency, business outcomes, you can see. So as we build AI responsibly, there are different parts we need to understand. Basically, trust and safety. Humans always in the loop to generate high stakes decisions. As we move on, it may change in future, but at least at this point, we need to ensure governance policies, trust and safety. And by properly applying AI responsibly, there is a huge national impact for the whole ecosystem. So the future is not waiting. The question is, are we leading it, right? So the interesting part is generative AI is not hype. We moved away from chatbots to agents. Every organization already running at least more than 30 to 40% of their workloads with agentic AI. And the intelligence is being built from past interactions so that it's going to become more and more intelligent. At some point, it started making more reasonings from a customer or a business perspective. So you can see the complexity of an agentic product setup. This is just a reference architecture. There are multiple parts of it, whether MCP, Graph, or all these technologies are being leveraged to power this up. So yeah, so that's all for my session. And interestingly, and these slides are also generated by agentic AI, sorry, generative AI with a couple of instructions from me. And the whole creation took less than 5 seconds. So you can imagine the power of where we are heading. Thank you.
Thank you, sir, for that exceptional and thought provoking presentation. Thank you so much. If anyone has any question, they can raise their hand.
So to learn on prompt engineering or good prompting, there are a lot of tutorials available. I think educative.io, there is a site whether they really provide a lot of subjects on prompt engineering. They basically teach you prompt engineering structurally. And definitely Khan Academy, you can find a lot of interesting articles, but even ChatGPT or if you ask Claude, it can share you a lot of resources on prompt engineering. So yeah, so prompt engineering, as I mentioned, is not just giving a text to the LLM. It has much more complicated things like tunings on temperature, different things. So basically, you can tune a prompt for efficiency to creativity. For example, if you're asking to write a novel based on instruction or a fiction novel, you need more creativity, right? Versus if you're asking a medical advice, you need more clarity or not just not creativity there. It is to be more clear, right? So you can tune this prompt engineering based on your use cases, but there are a lot of resources available on internet.
Thank you so much, sir.
Thank you.